Stott Pilates method guides us into the heart of the posterior chain while mobilizing our neurological organization, biomechanical alignment, and respiratory coordination. Lying face down, the body is placed in a posture of openness and awareness. The head is turned to one side, the pelvis remains in a neutral position, the legs are either parallel or slightly open to hip width, the knees are extended, and the ankles are in plantar flexion. The hands are gently clasped behind the back, as high as is comfortable. And already, before any movement has begun, the work is present. We're not just lying on the mat, we're entering into relationship with gravity, with our support points, and with the rhythm of our breath. The exercise begins with an inhale. It prepares us. The exhale that follows engages us. It activates the deep muscles of the trunk, the pelvic floor, the transversus abdominis, and the internal obliques. With control, both knees bend 3 times in a pulsing rhythm that is soft yet precise. These small pulses, although subtle, demand great pelvic stability. While the knee flexors are working, the deep abdominals must remain engaged to prevent any anterior tilt of the pelvis. On the next inhale, the legs extend again, reaching toward the back. At the same time, the hips move into extension, the legs open in abduction, and a soft external rotation allows tension in the knees to be released. The upper body lifts, not through brute force, but through lengthening of the spinal extensors, activation of the latissimus dorsi and teres major, and by a conscious retraction of the shoulder blades. This extension is smooth, gentle, and respects spinal alignment. Far from a forced lumbar arch, it is a thoughtful, intelligent rise, evenly distributed along the spine. The latissimus dorsi plays a central role here. This wide, fan-shaped muscle stretches from the lower back to the top of the humerus. It originates from the lower thoracic vertebrae, the thoracolumbar fascia, the iliac crest, and sometimes even the lower ribs, inserting into the floor of the intertubercular groove of the humerus. Its actions include shoulder extension, adduction, and internal rotation. In this exercise, the latissimus works in synergy with the spinal extensors to stabilize and open the upper body while assisting the arms in reaching toward the feet. It supports thoracic lift, contributes to scapular control, and promotes balanced extension. Above the spine, the splenius muscle is key to cervical stabilization and gentle head extension. This deep muscle includes 2 parts, the splenius capitis and splenius cervicis, and originates from the spinous processes of the upper thoracic and lower cervical vertebrae. It inserts on the occipital bone and the mastoid process. When both sides contract together, they extend the cervical spine and head. When working unilaterally, they create rotation and lateral flexion. In our exercise, the splenius helps maintain alignment of the head as the thoracic spine extends, preventing excess tension in the neck. Its precise action allows cervical lengthening without compression. What makes this exercise so rich is not just the muscular engagement, but the dialogue it initiates between brain and body. Each phase is a conversation. Each movement reflects a communication between sensory receptors, central integration, and motor response. In the muscles, neuromuscular spindles detect stretch, Golgi tendon organs perceive tension, and joint receptors convey orientation. These signals travel through afferent nerves, reach the spinal cord, ascend through the brainstem and cerebellum, and arrive in the sensory cortex. There, they are processed, organized, and given meaning. Then the motor cortex takes over. It plans the movement, adjusts it to intention, and sends the appropriate command. The descending motor signal travels through the corticospinal tract, crossing the brainstem and spinal cord to reach the lower motor neurons that will activate the target muscles. All of this occurs within milliseconds, a seamless, rapid cascade of perception and action. To understand this orchestration, we must examine the structure of nervous tissue and the differences between the central and peripheral nervous systems. Nervous tissue includes two main cellular families. First, neurons, excitable cells that transmit electrical impulses. Second, glial cells, just as essential, they provide structure, nutrition, protection, and insulation for neurons. In the central nervous system, which includes the brain and spinal cord, the main glial cells are astrocytes, oligodendrocytes, microglia, and ependymal cells. Astrocytes support neuronal metabolism and regulate the chemical environment. Oligodendrocytes create myelin sheaths that allow fast electrical conduction along axons. One oligodendrocyte can myelinate multiple axons. Microglia act as immune defenders. Ependymal cells line the brain's ventricles and help circulate cerebrospinal fluid. In contrast, the peripheral nervous system, composed of spinal and cranial nerves, has its own dedicated glial cells. The Schwann cells are responsible for myelination here, but unlike oligodendrocytes, each Schwann cell wraps around a single axon. This system serves as a vast network connecting the body to the central system. It gathers sensory data and transmits it centrally, then relays motor commands outward toward the muscles. Thanks to myelin and glial support, these transmissions are not only fast, but also precise and protected. In the double leg kick, this entire architecture expresses itself in movement. The body becomes a living network. The pelvis remains stable as the legs move. The spine elongates as the arms reach. The breath gives rhythm and coherence. Synchronization is not merely physical. It is cognitive, perceptive, and emotional. We can explore variations to deepen understanding. Practicing just the torso portion with legs grounded allows us to focus on arm coordination, scapular control, and thoracic extension. Alternatively, practicing just the legs while the torso remains on the mat, hands under the forehead, allows us to refine pelvic stability and feel the hip extensors more precisely. These are not regressions, they are educational tools. They allow us to dissect the movement, explore its components, and reassemble it with clarity. From a sensory perspective, they offer a